Hello, good afternoon, folks. I guess the energy is very low in this room, what I can see. Right? Uh, just for my sake, for my attendance sake, people who speak Marathi, please raise your hand. Who can speak Marathi? Okay. People who speak Punjabi. Okay, fine. Bhojpuri? Any Bhojpuri guys? Kannada? Okay, fine. These are my limits. Okay, beyond these languages, I will not be able to speak anything except English. Okay, little bit of Spanish, that's fine, right? Okay, any cricket fans? Oh, I see. Lot of cricket fans here. Okay, fine. Not my favorite sport. Any football fans? Fine. Formula One. Who likes to drive? Fine. I hope now everybody is awake, so we can start. Right? So, good afternoon, folks. My name is Mahesh. I represent MPL. It's one of the largest gaming companies in India. Today, we'll be talking about real-time ML platform. I have my colleague and co-presenter, Lakhan. He'll introduce himself.
Yeah. Hi everyone. So I'm working at MPL as a staff engineer. I'm passionate about building data products on top of real-time streaming systems. Yeah, Mesh.
Right. So, when you say ML systems, right, a lot of people just keep on thinking, okay, fine, very, very strong mathematical thing. But I guess in today's day and age, it has become very easy, right? And ML have started to become commodity. And a lot of people want to use it. But what happens is that training it and deploying it sometimes can be painful, right? And also using it as a commodity can be painful, right? So this platform solves that purpose. Over here, we'll probably give you some idea about how it can be done, right? And rest of that, I guess, a lot of smart people here, they can figure that out. So let's start. In this particular session, what we will generally figure about is why it all started, why we need ML related things, ML platform, everything else. Next, basically, oh, I can do that from here.
Yeah.
Next, basically, why we need ML platform. Next, we will understand why real time. Okay, we can do it offline also. Why real time? How to design one? Okay, it's fine. You told me why real time. Then how to design one? Then basically some components of ML platform, feature engineering ML on inferences. We'll don't worry. These are buzzwords, but we'll go into detail of each of them. Then some benchmarks, how fast it can be. Some business benefits, because see yaar, paise ki bina to kuch nahi hota, right? At the end of the day, what drives tech is just money. So why it all started? So let us go back to the early age of technology. Let us say 1990s, probably 2000s, or maybe late 2000s. So what we used to do? We had a system like this, distributed system just had started up. Okay. Then let us say it's a gaming company. I'm from gaming background, right? So I'll just give an example of gaming company. Let us say user logged in. There are a couple of users who said, okay, we are logging in, right? And then basically all of them logged in. Sab log log in kar liya. And one of them got a response from login, and you showed that person Ludo. Any Ludo fans over here? I used to play a lot when I was young. Okay. I guess you both of us are in the same era, probably. So then basically that person was happy because he was nostalgic just like me, and was very, very much happy, right? Second guy also got probably Ludo again a suggestion, but that person did not have nostalgia like some people sitting over here. They said no, they do not like Ludo. So they said, okay, I'm fine with it. I'll still play. You have shown me. The other person also got the same recommendation. He was okay. And the last person, probably the latest generation, haven't played Ludo, right? They were unamused. Why Ludo? I don't need it. I'll play Monopoly, right? Probably. So yeah. And this is quite generic. Only one was happy, rest of them were unhappy probably. Some of them were okay. Let us say you're not playing any game. You just logged in, okay? And you are making a deposit. People make deposits, right? In your UPI app also you make deposit. You're making a deposit. And that system decided, yaar, main sabko offer hi dunga. I'll give offer to everybody, right? So what happened is that one was playing a game, other logged in, and that person got a offer cashback of 8%, deposit offer 8%. That person was happy. Okay, fine, I am depositing and somebody is giving me offer. Why not? Indians, we want offers. Give me as many offers as possible, for sure. Other person also got an offer. He said, okay, fine, you are giving me. I do not say no to the money. I'll always take it. The other person said, okay, I'll also take it if you're giving free money. The last one said, I am rich. Why you give me offer? Give me something else. So he was unamused about it. Now, what are the shortcomings over here? First of all, these are generic and may not be a very relevant recommendation for each of the users. Little to no personalization, generic user journey, little bit of poor user experience, may lead to user retention. Why? Because see, if you do not like the product, what will happen? You will not open your app. If you do not open your app, what will happen? Low retention. Probably can lead to growth stagnation. You may go up there and stay there for a longer time because a lot of people are coming and going down. Like, now, we got to know that's fine. Like, itna sab to soch liya, right? But these are not. This is not how it should work. So how we can make it better?
Thanks, Mahesh. So now we want to build recommendations which actually impacts our users, but how to do that? So we start doing with first step, which is cohort analysis. This is something like we have user data, which is logged somewhere. Every activity user is doing, it is getting somewhere tracked as a user action data. And we hire some analyst. That analyst, he does a lot of analysis, finds patterns, and identify, okay, there are set of users who like something, and there are set of users who like some other things. So it builds the cohort of users. These cohorts of users now need a dedicated recommendation. Those recommendations also identified by analysts. Cohorts, recommendations going through systems to actually the end users. These end users now identified, we know like some users have affinity towards now depositing the amount. Can we give cashback offer to them? Now we have curated our decision to those users. There are other users who we know they like to play casual games here and there. They come and then, okay, play a game of Ludo, which is a casual game. Whenever you like, you can just play a couple of games. There are users which are like there on your platform, on app. Every day they are playing. They have reached some milestone. What they need? They need some rewards on top of their achievement. So you give rewards for them. Now you have come up to the stage where cohort-based offers are given. This cohorting is helping us, but it's still a hit and try. Someone who is playing a Ludo game, he might be playing at same lobby points which he is not interested in. He is getting offers to or recommendations to play at let's say 5 rupees, 10 rupees, 100 rupees lobby, but he might to play some other lobby. That personalization is not there. So we start thinking about what next we can do. We challenge our analyst, hey, can we do better? So we go to the next step of building a decision tree. So every user actions is actually giving us indication where user is and what he can do the next. To drive user through your app, you need to build user journeys, right? This user journey is actually taking to a desired outcome of your app. And these outcomes can become a decision tree. You do action one, okay, there is action two. You have to recommend it user. You have to guide user to that journey of flows to actually benefit users what he wants to achieve. Throughout these decisions, throughout this recommendation, what we are following, now instead of cohort, we have moved at the user level what they should have. So some users who have low wallet balance or they want to deposit something at certain point of their journey, we give them offers that point of time. Now some other users who are playing card games, let's say Rummy is someone liking, he's playing day on day. Okay, next time he comes, what we want to give? Play other card games, play poker. Why not? It is similar, right? You can, you like it, you play it more. Some other users who are not liking card games, they just want to still stick to the casual playing one off time. They will get Ludo recommendation. That is how we are going towards a cohort to user level personalization. And this is improving our systems. Here drawback is your decision tree is still generic. All the things you are deciding, all users going to same stages. There is no personalization which is actually taking consideration of users' data. What is his interest? Someone can be high roller, someone can be low roller. So that information is not there. Okay, so analyst again comes back. He decides what I can do. I need to take users' decisions in users' information into consideration. Those, if I consider those user signals, what user is trying to do, then I can build rules for those kind of users. then it is becoming a journey for high roller is different, journey for roll roller is different, and that is actually giving you user-based rules. Every action for that user can recommend even better recommendation. We have reached a stage where we are actually taking decisions for user for what they want to achieve. In this journey of driving recommendation, our analyst has worked a lot. Day on day, he is trying to improve. Week on week, he is improving things, but it is still a human-driven behavior, right? Can we do better than this? We need to automate this. Analyst is learning the patterns. He is finding some recommendation, and he is improving it day on day. This is a classic ML model behavior, right? So if you just bring in ML models, which will try to learn this pattern, recommend this, what user needs at that point of time. And it can improve day on day, right? Day on day, ML model accuracy is improving, user journey is benefiting, and what we wanted to achieve, a machine learning platform, is something can be built on top of this. So just to summarize, we started with like level 1 mathematical cohorting. We identified based on patterns what cohorts and what generic recommendation we can do. Step 2, decision tree, math rule engine. We created generic decision tree, which actually giving user better recommendation as per their actions. When we started using the user personalized details, user's profile, and curated our rules decision tree of rules using intelligent profile of user, that's when we started achieving the highest level of user personalization. As we move forward with the better intelligence, we tend to delegate this all activity to ML models, and we start building, training ML models in and deploy it. That is where the basic ML platform foundation starts. So what is ML platform? This is our interpretation. This is our definition of ML platform. Like resources, environment, which actually our team, data scientists, researchers, engineers needs to build, train, test, model, and deploy them in real time. Such frameworks, such set of tools, such infrastructure will actually collectively called as a ML platform. To continue on why we need this, it is like automation of intelligence, which actually learning the data and recommending the recommendation in faster, smarter, real-time way. And it will also help our team to build a streamlined workflow. They just have to worry about what ML models to build. But what workflow it will run in actually the production, that is something you can streamline. Building platform will bring you scalability. It will also bring you cost efficiency and actually the personalized user experience. Most of you might be thinking, have I already experienced it before? All of you are using OTT platform, right? Any movie you see, you get similar recommendation. Similar genre, actor, director, those kind of recommendation. Anything you want to purchase on e-commerce or quick commerce app, there you buy a furniture, you get recommendation to decorate the furniture. These kind of systems are already driving your behavior day to day on actually achieving what you want to do on the platform. So how to build one, Mahesh?
Right. So now everybody got to know why we need ML platform and what are the benefits out of it, right? But how to build one ML platform? That is the question we're going to answer today. Probably in holistic view, then we'll probably go in details, right? So there are various modes you can run your ML platform. One is the batch mode, where basically you have the data, you train your model, you train the elephant, and then basically the relevant walks and gives you alpha, right? How to do that? First, you have app data. Whatever instrumentation, whatever actions you do in your app, basically, that is nothing but as clickstream data. That is all instrumented, logged, and sent it to Kafka. Then basically you have user actions. When I say actions now, these are nothing but actual user actions. For example, you played a game, that is again user action, right? Basically, you made a deposit transaction, that is again user action. Then you have transaction data. For example, you deposited, you withdraw, right? You won. A lot of people like winning over AI. I'm pretty sure about it, right? You won you lose, that is also one action, right? User transaction. All of this transaction data is sent to Kafka. Then basically what we do is that we put all of this data in data lake. Believe me, there is a lot of lake in this word, but there is no water, it's just data, probably flowing like water, right? So we put all of this data in data lake. Now this data lake is totally unstructured data. We cannot use that data directly to make any kind of decisions. So what we do, we extract some matrix out of it, extract some measurable data out of it, right? For example, I'll give an example, right? If everybody owns a house over here, right? The area of your house is something which is measurable, can be used to make a decision. For example, I want a 2,000 square feet house. Somebody who's richer may say, I want a 5,000 square feet house. Somebody like me will say, I'm okay with 800 square feet house also, right? So more or less, so we convert all of this data into measurable points. Those points are called as features, and that is stored into feature store. Now, after that, what happens is that you have your hulks over here, probably Spark and Hadoop. Basically, you get all of these features, train all of your models on these features, basically. Then what you can do is that you will put all of that inferencing into a personalization database. I have named personalization, but this is nothing but an inference database. Okay. Now, what will happen is that if, let us say, there are certain things which you need an immediate action. For example, if you have an offer which you want to give, you would like to see that offer when user logs in again, or basically you would like to show that offer immediately as soon as it is generated, right? Because offer is something which is very lucrative for somebody, right? So that will directly go to the edge communication, and then basically user will get a buzz. रात में सो भी रहोगे ना, फिर भी बजा कर उठाएगा आपको, something like that. Okay, more or less. Now there are certain things more like, for example, I was playing Ludo, my era people, right? And somebody may like Snakes and Ladder, right? Again, my era people. So for those people, for example, you have recommendations of other games. So when the user logs in, it's okay for you to show. That will get stored into personalization database, and then basically user will come, and basically when the user logs in again, that homepage will display with new recommendation. Okay, I'm taking gaming examples. There are a lot of other places where this is used, probably e-commerce also. So this is batch. Now batch is fine, right? But doesn't feel still very, very real time for me. Like I made an action, I got an immediate recommendation. That feeling is really good, right? Instant gratification is what user want, right? How to do that, right? So over here, again, we have clickstream data. Then we have user action data. Everything will go to data lake over here again. But over here, there is one more layer. We fork this stream over here itself, and we will say, fine, we will not wait for the data lake to sink in and then create features. We'll tune those parameters here itself. We use Apache Flink to do that. We have different kind of things. For example, we have rollups. Everybody know rollups, right? For example, how many games I have played in last 30 minutes, a rollup, right? Probably Windows. Then we have features. For example, what is the total amount of deposits I have made in last 1 year? Again, a feature, right? You calculate all of these features in on the fly and immediately put it into the feature store. Then basically, there are some trigger events. For example, I'm at a deposit and I want to give an immediate offer to you. That basically events acts as an anchor event. It will go to the orchestrator. It will trigger over there. And then basically it will go to the inferencing layer. It will go for inference. It will inference that event basically and fetch the features from the feature store. And later on, it will take some configuration from the A/B experimentation, put it into the Kafka. Then it will go to the edge layer again, and then buzz the user. Now this is very immediate, right? As soon as you made a deposit or initiated a deposit, you got an offer, deposit offer, probably a cashback offer, right? This is how ML real-time ML system works. Now, this also can be used for better recommendation. As soon as I was playing a game, as soon as I went to the homepage, I saw the recommendation of other casual game which I like probably. Okay, maybe I got recommendation of Ludo over there. So that can also happen. And this is again the same flow over here. So this is how a real-time holistic view of real-time ML system looks like. Okay, right? So over here, the key components you can see over here of any real-time system, ML platform systems are feature store, which is more like the store, the tuned store of the ecosystem. Then we have ML inferencing layer, which is like the brain of the system. Then we have orchestrator, which is more like our heartbeats keep on ticking, right? It is needed, right? Heartbeat is also needed. Yeah, anybody who can live without heartbeat over here? Probably. Anybody? I was looking for an exception, but there is none. Okay. And then basically we have experimentation platform and observability. Now, in any kind of system, right? You really trust your systems for sure. But do you trust yourself writing code? No. You need some observability over there, right? So there is an observability layer which basically keeps on monitoring that, keeps an eye on what your system is doing, right? So that is one more layer which we have. And this whole highlighted portion is nothing but a ML platform. Okay, so we will go component by component of this ML platform. Probably we'll start with the storage layer of the ML platform.
Yeah. So we have now 4 pillars of our ML platform: observability, ML inferencing, orchestrator, and feature store. Feature store is, as Mahesh explained, if you have a house, what is the square feet? What are the windows of house? How many? How many rooms you have? Height, width, all that is the features of house. Similarly, we need to find user's feature. What signal user is giving you, what pattern he is using, how many games he has played, what he likes to play, which game he likes to play, at what time he likes to play. All that becomes a feature for you to drive user's journey. So how to define a feature? We have a config store where we define different types of features. We have classified our features in these types. We have counters, like everything is can be counted, like number of gameplays, how many days user was active. That is a counter. There are mathematical functions you can use, and actually using multiple values, you define some outcome, which is a feature. Some standard deviation, some mathematical equation, which is giving you actual better signaling of what user is doing. Then there are roll-ups. If user is playing now and then, what is count of games he has played in hour? Can you get that information? If you can use it to better decide what user will play, that will help, right? So that is roll-ups. And then lifetime fixed values. User, when did he first logged in? What amount he deposited first? These are very critical information to decide whether user is high roller or low roller. That information will not change in user's lifetime. So we support those lifetime fixed value as well. All defined features has to be computed. This will be done by feature compute layer. Now this is powered by Apache Flink, who is enabling us to consume the data which is coming in real time in Kafka, consume it, process it based on our definitions, and actually computed data will be sent forward to storage layer. Here storage layer we have used BigTable. BigTable is nothing but persistent write optimized database. This is a wide column family database which allows you to store data in lexicographically sorted manner. How does this help? Every time you query the database, you want to query for certain time window. In last 1 day, in last 7 days, in last 1 hour, what user has done. And based on that, you want to use that recency of data to actually gauge what we want to do. That is something is enabling us at scale by this big table. Then we also use cache Redis. Now cache is used for features which are used very frequently, high throughput queried features will be stored here in storage level. After that, we have a serve layer. Now serve layer has two purposes. One is feature discovery. What features are already built that we can use, how to configure them, and actually serve it to the external system. In ML platform, usually your ML inferencing or orchestrated layer is going to extract this information and use it in the inferencing. This is how serve layer is getting used. So these are the component of feature store. Similarly, we have orchestrator. Now this is a ticker of ML platform. Or there are two main important points which orchestrator is solving. One is allowing you to build a workflow for your recommendation. What are the steps to reach to a decision? That is something orchestrator will allow you to give. It will orchestrate that workflow, and it will also enable to give a trigger point when to take a decision. When action happens, that time you want to take a decision. That is something orchestrator will enable you to do it. There are two types of trigger points. One is scheduled, another is event-based. Scheduled is something like you want to recommend in the morning, in the afternoon, in the evening, something else, right? That is something you want to do it on scheduled basis. And event-based triggers are something like user activity, clickstream-based, or whatever is happening in the backend when user is playing game. That time you want to decide an anchor event and choose to trigger a recommendation for that user. That is event-based trigger. So when I said workflow is something orchestrator is going to orchestrate. It starts with the pre-command. These are like set of predefined commands that you want to use for your ML workflows. Something like which ML models to use, which configuration to use, what features to use, what is state of users, do we need to pull those features, all that information pre-command will do. Then there is a DAG. This is directed acyclic graph of models. So to come to any recommendation, you have to go through multiple model decisions. Now I will give example, like we are a gaming company. User comes to a platform and he wants to play a game, what to recommend. Now this is a multi-step decision, multi-step recommendation. First model will tell me whether user will like to play casual games or card games. He likes to play casual games. Okay, I have 10 casual games. Whether he would like to play Ludo or Snakes and Ladder. I gave him Ludo. Another model is deciding that. Then there is a next step. You want to play Ludo, but okay, what format? One-on-one or multiplayer? Whether you want to play at lower lobby or higher lobby. That is all something can be decided by another model. So every model is actually deciding one decision, and that chain of decisions are actually curating your recommendation through this DAG. Of course, DAG uses ML inferencing at each step to come to a recommendation. And there is a post command. This is nothing but an adapter which takes the recommendation and based on user journey and what would be the downstream system, what they will need. That is something customization post command will do. And this will go to inference store or actual the edge layer communication where actual user will get the benefit of the journey.
So we got to know certain things about it. What is the storage layer? How we store the data over here, right? We got to know what is the ticker, what is the heartbeat. Now we'll study about the brain of the ML platform system, right? ML inferencing, as name suggests, it is nothing but farm of models which act on an input. Okay. So initially you have an orchestrator. Of course, it is going to tick and say, I want this decision on basis of an event, or probably it will on a schedule, on specific schedule. Okay. It will go and trigger a decision graph. Now, people from data science background over here, anybody? A lot of people, right? Okay. So in case of one category also, there are multiple submodels, right? Okay. So this decision graph is a graph of submodels in the main decision center. In that, basically, which model you need to call for each step of this graph, there is a router. Which model? For example, if you're doing A/B testing, I want to call a version 2.1 of a model or probably version 2.3 of another model, right? This is nothing but routing layer. Then there are pre and post processor commands. For example, output of one model can be input of another model. It may need some formatting, may need some transformation. So this pre and post processor basically take care of that. Then it will go and take the data from the feature store and then basically go and call the model farm. Model farm is just like your farm with different crops. There are different models, different versions of the same model. It's just like a serving layer over here. Okay, you can see there are different versions of the same model, version 1.1, 1.2, and then there is another model with 2.4, right? So as soon as this model farm is called, it will return the result to the decision graph. Again, go back to the router, and then again call this model. Then process will repeat till we reach the end of the graph. As soon as we reach the end of the graph, basically it will call the post processor and then basically spit out the decision to the orchestrator. Okay, that is how the brain of the ML inferencing ML platform works. Now, I understand there are all these things like we have feature store. Oh, good, right? Then we have orchestrator, really, really awesome, right? Then we have the brain of the ML platform, that is ML inferencing. But even in a classroom, right, there is always a teacher and there is a monitor, right? Everything needs monitoring, and we need an eye. We need to keep an eye on everything. The first thing which we need to keep an eye over here in this particular system is, what is the first thing we need to keep an eye on? Your models, right? If they are behaving correctly. Now, how you understand if the model is behaving correctly? When you make a model, you have a hypothesis that it should work in certain way, right? So you set those parameters, and then basically you create matrix around it, instrument those models, and then basically you track whether there is a deviation from your expected output to the output your model is giving, or you will also track general confusion metrics like precision, recall, accuracy, all of these metrics, right? You have these metrics now, but if you want to function your model really well, you need to have really, really high quality data, right? What can happen? What can go wrong in data? Data can be out of sync because this is real time. This is no more batch now, right? Data can be out of sync. There can be invalid values, right? There can be values at lag. Okay. So all of these things, they are measured and maintained by a data quality assurance system, which basically tracks all of these things, alerts you, or probably makes corrective actions on basis of that. Now, this is really machine stuff, but we are humans, right? We want to see really beautiful dashboards around it. So there is a reporting engine which generates all of it dashboard, and you can set alerts on that. Now, this is all about model and business monitoring, but there is an underlying hardware system going there, right? Engineering system going there. How will you monitor that? So we have system monitoring around it, which basically collects all of the golden metrics. What are the golden metrics? Error, throughput, and latency. These three golden metrics. It will also collect rest of the metrics like infra metrics, for example, CPU, memory, network, and it will detect anomaly. It will do an anomaly analysis or anomaly detection on this, or probably it will. We can also set thresholds on that. Now, we have done with model monitoring, then we have done with quality of data, then we have done with probably system monitoring, then we are done with reporting. But there is one more thing. Who is configuring all of these experiments and models, right? Probably a human. We can make mistakes, right? Or we also want to track what all actions we are doing. So we have an audited and tracking system which basically tracks all of the actions which are particularly made on this particular system, right? So in case something goes wrong, we can immediately revert to the previous decision which we have made or previous configuration which we have made. So this is an audit system. This system collects data from instruments and collects data from all of our three main components, that is feature store, ML inferencing, and orchestrator. Okay, so this is a very brief overview of our ML system altogether. This is the observability stack. Now, in case of system monitoring, in case of model performance monitoring, we have built our own system using open source stack. In case of system monitoring, people familiar with OpenTelemetry must be aware, right? OpenTelemetry, right? So we are using standard protocols for that, more like OpenTelemetry. Audit and trails are pretty standard systems available in the market, open source. Now, it's fine. We have made all of this system, but what benefit it brings to me as an engineer? So the first benefit it brings to you is that user profiles. Okay, it gives you a really good user profile. So you do not need to maintain those user profiles at different spaces. Everything is at a central place. And you can create accurate and dynamic user profile for targeted insights. It will make analysts' life easy, and it will make your life easy as an engineer also. You do not need to actually formulate it again and again. Then real-time decision making enables faster response to market changes. Believe me, I'm not talking about stock market over here. Okay, these are generally user action changes. Okay, like whatever actions you're going to perform. I know it also goes up and down. There are changes over there, but this is not that. So then probably AI-driven model to process data instantly, ensuring immediate action. User journeys, for example, a journey for a new user would be different, and a journey for an old user would be going to be different. For example, new user would like to understand how to play Ludo, right? An advanced user will say, give me a hard level, bro, I'm pro, right? So observability, tracking, monitoring of business and ML model. And basically, we also do proactive issue resolutions. Data quality assurance. Now, this data quality assurance, I understand that it is built for ML platform, but this is going to take care of your overall data quality also, just not ML platform, right? Because it is keeping tap on what is going wrong in the data itself. Experimentation, product people over here, any product people over here, you know, right, how painful it can be if you want to create an experiment. You have to go there, configure, and then basically sometimes you have to request the engineer itself, please write this code for me. I want to do this experiment, right? So this probably gives you a self-serve movement where you can basically just on configuration basis create an experiment and track it. Self-service, we have made it self-service as of now. So it really reduces the dependency or directly on the core engineering team, so they can focus on larger problems. Now, these are some stats which I want to give an idea about. So whatever system we have built, and it approximately does more than around 300 million inferences per day. End-to-end turnaround latency is P99 is 10 seconds. P90 is way lesser than that, right? We process around 150 million features per day, and the refresh rate is less than 100 milliseconds, right? So as soon as data is produced, in less than 100 milliseconds, you get that in the feature store, and it is available for processing and experimentation, right? Now, it's fine. We talk about tech, we talk about ML systems and everything. Business people here are going to ask how much money it is going to give me or boost it is going to give me, right? So what are the business benefits over here? First is user personalization. The more personalized and intimate experience you give to the user, right, the more user are going to stay in your platform. For example, if and e-commerce players give you exact recommendation what you want. You're going to stay to that platform, right? Similar way over here, in all of the industries, personalization matters. Then, personalization doesn't mean that exact recommendation, but also new versus old users sometimes, right? User preference and missions. For example, people who have played Subway Surf here, anybody? Right? A lot of people. Yeah. I do it when I'm sitting in a cab or probably bus, right? So in any kind of game, if you see, there are tasks. In some cases, they are collecting alphabets. Some cases, they are collecting goods. In some cases, they are playing more number of games to achieve X number of mission, right? So user preferred missions. That gives you more engagement because you get adrenaline rush as soon as you complete that particular mission. Then user preferred personalization rewards. For example, if you give reward on particular task, basically that gives you more adrenaline, and more adrenaline means you will play more, right? More or less. Offers and personalization benefits. Rapid experimentation, that is one of the benefits over here. You can do a lot of experiments very fast, and what happens is that you get to know things if they're working or not. For example, if you create an experiment, switch it over to smaller cohorts and check if it is working or not, and then basically you will say it's working, you will give it to all of the people. Reporting, auditing, tracking, personalized recommendation of the product across the basis of user preferences, which basically will increase the app engagement and activity. Resurrections, for example, if a user, he's playing for couple of like good amount of time now, right? And probably you are seeing that the activity of that user is reducing. So you can probably give something exciting to that user and increase the activity itself. Okay. Better player match based on their skill. Now I'm coming from gaming industry, right? Okay. Any chess players over here? यार chess बोलते ही कम हो गया क्यों ऐसा why nobody likes chess it's fine so chess players so how many you like playing with a newbie over here less number of people, right? But newbie playing with newbie will enjoy it probably, right? Probably the skill level matters. The more skilled you are, basically you want to have a really good opponent, or maybe you have to you want to have a really fair battle around it, right? So this gives a really better matchmaking based on the skill. How much skilled you are, and based on that you will get a better match over here, and you will have a fairer battle. And more fairer battle you have, better you enjoy the game. Okay, that's all from my side. Do you have any questions?
Hi.
Yeah.
So I am Arghya Mukherjee, and I think I'm really like the way you approached it. Just a question here. So this entire like the ML platform is open sourced, right? So like you have taken all the components and all, and for example, it's like you have like build it like think about the observability layer, think about the feature stores and all. Tell me one thing, that same thing, it can be built on one of the hyperscalers also. Think of AWS or, for example, Google Cloud, who gives you the pre-built components. Like instead of using an open source feature store like Feast, right? You can just use an like SageMaker to do it, right? So do you think what would be like how do you design the entire ML platform, whether like like you would like to go for an like one of the hyperscaler, or let's take the open source and stitch it through it? That's the question.
Right, so I'll answer that. That's a really good question. First of all, it depends on at what stage you are and how you're building it. Okay, to start with, definitely you will build versus buy. You will buy something right out there in the market because you're starting up. But as you go ahead and your requirement becomes more and more complex, right? So customize. You have to make more and more customization. And when you go for rapid, like more, for example, if in the market X amount, X platform is available, and if you want to do more than 50% of customization, for example, right? You will say that I'll prefer building my own because then I can provide all of the features. That is how you have to approach. You can use any of the tools which you have mentioned to start with probably, and probably you can also use it all way long also if it satisfies your requirement. But in our case, basically we have to do a lot of customization, and that is the reason we have to choose to build our own.
For the processing part, you said Flink, and
Yeah.
basically, where do you're using Apache Flink standalone, right?
We are using Apache Flink as of now in cluster, yeah.
For of the Confluent or your own cluster? Because on the Confluent they don't provide data stream API.
So I'll tell you, it depends on the requirement. We have certain things which we had to use our own wherever it was necessary, and rest of them we use directly, which is available out there in the market. It depends on the requirement. At certain places we had to use data stream API, so there was no option for us, right? So we have to maintain our own.
Yeah, so basically what we are doing, like if when we take the source Kafka and do some processing and dump it to again a Kafka topic.
Okay.
So there's some delay in the source and the merged topic. So there may be some.
Yeah, so that you have to think very diligently and intelligently. I'll just tell you. Uh, Generally, I prefer less number of hops in my system. Okay, I try to find a path which will have the least number of hops. For example, there is clickstream event, there is enrichment pipeline in between, there is only one hop in between. There were multiple hops initially in my pipeline also, but I have collated all of those hops into one particular thing. And I've made that system generic, so it can basically internally process it, internally send the data into each other, and then basically create a hop. So that reduces your lag as such. Because see, any queuing system is going to have some kind of delay or lag that you cannot avoid. So you have to design such a way that you have minimum number of hops, or basically you have to say what is my tolerance. For example, for some systems 10 seconds is okay tolerance. For my systems generally 1 second is also a higher tolerance tolerance level. So you have to think through that what is your graph you're making, processing graph, and create a DAG out of it, and then basically design your system. For us, we have created a platform, so we configure it so it becomes easier for us to change. Yeah.
Hello. So first of all, nice presentation. Secondly, the use cases you talked about were mostly around recommendation and offers, right? For this presentation.
Yeah.
Pardon me if I'm new to ML engineering. So pardon me, but why when you were talking about inferencer, you mentioned like you had like different models, right? So I wanted to ask if we are talking about the same recommendation system, so why there's need for different models? Wouldn't we want the response to be consistent, and on like what basis we choose different models? Or is it
I'll answer that. When I said different models, I said use case wise different models. For example, choosing the category one model, choosing the game another model, right? In case, for example, you have built a new model, you will have version V1 of the same model, version V2 of the same model. You will experiment and then basically make the other one live.
Okay. And like when you are experimenting, so how do you know how do you know the response, like which model response is better?
You have monitoring for that, right? You have hypothesis, you have instrumentation. On basis of that, you understand if the model is performing as expected.
Achha, so is it like some sort of based on some feedback?
For example, I'll give a very easy example.
Just one minute.
Engineering. I'll give an engineering example, right? For example, you said that you want to process 100 and let's say 2 million requests per minute. Okay. Yeah, you have 10 servers, example, right? And if your 10 servers are only serving 1 million requests per minute, you will get an idea that this is not performance I'm getting out of it. So similar way, models also, we can instrument the data, output data, and instrument the matrix what we want to check how that model is behaving. Is it behaving as expected what I wanted? Yeah, this is an example I gave, but for matrix, I'll have to go and explain in detail what model you have and how you can measure matrix around it. It will have different matrix for each other model.
Cool, got it.
Yeah.
Hello. On the continuation on the same question. So you showed different models, right?
Yeah.
So I don't see any feedback in the real time.
Space. There was no space for me.
Okay. So,
but there is a feedback.
Okay, but you are taking feedback and improving the model on the real time.
Yes.
Okay.
But depends. Some use cases, they just want a standalone model. For some use cases, it is a recommended system, so it needs a feedback. Depends on the use case, but there is a feedback loop over there.
Okay. Thanks.
Yeah.
Hi. My question is around the orchestrator. So basically what we have is there are events or triggers that start some well-written script and they go on. So I like to frame it around the scalability, that as the system grows, one of the issues that we are facing right now is that it sort of gets out of hand. By that I mean we have an unknown, for some reason we have a wave of incoming data. There are too many triggers, and now my lambda is just scaling and then I have a very huge cost.
Right.
So in this case, in your experience, we want to understand because you have those sort of scale. What do you think? What
See,
sort of
I have faced all of these things. I have faced misfired events. I have also faced events where it went out of sync and everything else. So that is the reason, as I said, right, there are systems which are available in the market. It's scaled to a level, and after that, if you feel, you have to customize it. So we had to build our own scheduling system for that, which used to do all of those things.
Yes, so we have tried that where essentially instead of having lambda triggers, we can say that okay, there is a big vertically scaled machine that essentially is taking instead of one lambda job doing one thing, now this machine is taking a batch of 10 and trying to do it. So batching those things, we are trying to reduce the latency because if even with lambda because of the cost restrictions it starts to have a backlog, right? But even then it's like at this point the only solution we have is vertical scaling. So in your opinion it's
No, so see, Lambda is executing your command, right? You can build your own command executing cluster and framework, and you can deploy those commands on the cluster itself. So you have control over your infrastructure. In that case, what happens is that it becomes easier for you to scale the infrastructure you have, the fabric which you have, and you can basically scale the command executing layer also. That will get deployed on multiple distributed servers. So that is how it happens. Lambda, I do not want to talk about very specific product as such. That is what choice you have made, right? Some choices we have made on ourselves. We have created a fabric around it, so it becomes easier for us to execute those commands. So we treat each execution as a command, and then basically deploy it on our fabric, and that executes it basically. That is the reason we had shown pre-command and post-command. If you see, yeah. Thank you, folks. Have a nice day.